Next, the fourth tool, which is in measures of shape, that is histogram. This is the last tool in measures of shape out of kurtosis and skewness. And but this is not the least one. This is widely used one, so which is histogram. So histogram is a graphical representation of the data distribution using bins or intervals. It shows the frequency or count of values falling within each bin, allowing for visual inspection of the shape, spread, and central tendency of the data. Let's see one example which is on your screen on the right side. So again, I just want to reiterate, histogram is a graphical representation of the distribution of a data set, and it is an estimate of the probability distribution of a continuous or discrete variable. In a histogram, data is divided into a set of bins or intervals, and the number of data points that fall into each bin is represented by the height of a bar. The bins are usually represented on the x-axis, while the frequency or count of data points falling onto each bin is represented on the y-axis. So let's looking into the each of the component of an histogram now. So let's begin with bins. So bins are intervals or ranges that divide data into groups. These bins are represented on the x-axis. You see that the bins are represented on the x-axis and are typically of equal width. The choice of the bin width can affect the appearance of the histogram and the insights obtained from it. Too few bins can result in a loss of information. Very important point to be noted while creating a histogram or while creating a customized histogram. Too few bins can result in a loss of information, while too many bins can result in a noisy or cluttered histogram. So it should not be neither few nor too many, neither too few nor too many. You should have an optimized number of bins so that you can get the actual you can get the histogram which represents your data. And next one, the next component is the frequency or count. So frequency or count, the frequency or count of data points falling onto each bin is represented on the y-axis. On the y-axis, it shows how many data points fall into each bin, which gives an idea of the distribution of the data across the bins. Then finally, bars that you can see on the screen. Bars. So the bars in a histogram represent the count or frequency of data points falling onto each bin. The height of the bars corresponds to the count or frequency of data points in each bin. The bars are typically drawn vertically, but they can also be drawn horizontally. So histograms are useful for visualizing the shape. Histograms are useful for visualizing the shape, spread, and central tendency of a data set. So they provide insights into the distribution of the data, such as whether it is a symmetric or skewed or bimodal. So histograms can reveal outliers, gaps, or clusters in the data and can help in identifying potential data distribution patterns. Let's take one example. Of course, we have taken a lot of examples so far, but specifically, I just want to give examples one more time. So 3, it's histogram. So histograms are useful for visualizing the shape, spread, and central tendency of a data set. So let's take this example. The data, let me call the data. This is our data frame data. Sorry, this is our sequence data, which is our sequence, a simple data set. So now what I'm gonna do is with the sequence, I'm gonna create a histogram. Okay, let's do that. So let's import matplotlib also. Import matplotlib. From that I want pyplot, and I want to import with an alias name plt. So our data set is ready. Now let's create a histogram using pandas. Let's create histogram using pandas. So df, that's our data frame for histogram, dfh, then pd dot data frame. Let me convert the data into data frame, data, and then data. So okay, there is some issue here. Let me solve it. Let me paste it inside that. Yes, that's it. DFH, and your data frame is ready. Now let's make an histogram. DFH dot histogram hist method. So column, we have to define the column. So column, I'll go with the data. That's a basically your sequence. Data is your sequence. Then we have the bins. Bins, I'm gonna go with the 5 bins. And edge color, I'll go with the black. Sorry, black. And here is your histogram. But before that, let me add X label, Y label, and title, and finally let me show X label. So X label is value, then plt dot Y label, that's again frequency, then plt dot title of histogram of data. That's it. The X label has been added, Y label has been added, and the title also has been added. Now it's simple. Just let's say plt.show, and here is your histogram. And from this histogram, you can make out the certain aspects such as skewedness and the kurtosis, and then range, and a lot of other stuff, whatever you want to make out. So in this example, a histogram is created using the hist method, and then in pandas with the data column in the data frame used as the data for the histogram. The bins parameter specifies the number of bins or intervals to use, and the edge color. So parameter sets the color of the edge of the bars. The resulting histograms shows the distribution of the data points in the data column across the 5 bins, with the x-axis representing the values and the y-axis representing the frequency or count of the data points in each bin. Let me take players data again, just one more example, and then height. Yes, let me say hist. Yep, we got it. Now let me try to add bins customized. So rectangular dot set called an unexpected keyword argument bin. That's okay. So that's what. Let me execute hist. Let me give the bins and then edge color. I'll give 6 and then C. So still the shape is fine. Let me give the very few bins, 3, and this is what the shape we got. If the bin shape is, if the bins, the number of bins are reduced, it's no more gonna represent the proper one. So that's why the number of bins that you're providing is also very important. Okay, so the bins, uh, too few bins can result in the loss of information. So that's what is happening here. Let me take the same, or let me add edge color to this. Edge color is equals to black, and you can see that edge color of each bin. So too less or too few bins is actually spoiling and a loss of information. Now I'm gonna go with the too many bins and see what's gonna happen. So I'll put a 12. Yes, oh, still it's looking fine. It's by and large taking up the shape of this thing. So how many bins they have gone with? Let's give, no, this is not too many bins. It's actually taking the shape of the normal distribution. By and large, you see that, you see this, if you just drop a curve on top of it, and this is how you get, this is how you get it. Okay, let me make one more histogram without a specific number of bins, without mentioning the bin numbers, and see how many will get it. We got I think by and large same. So 1 2 3 4 5 6 7 8 9 10. So 10 bins, and I've taken 12 bins. So however, the 10 bins is giving the exact shape, not exactly, but somehow it's closer. You see that this and this is at the same level, this and this is at the same level, this and this is at the same level. This is slightly falling down on this side. However, you got the by and large similar to the normal distribution curve. Normal distribution curve. Okay, that's how the histogram makes a huge difference in understanding the shape of the data.